Here's some answers for the 22nd of February energy, work and power. So a mass of 5 kilograms, and of course that mass will have a certain weight or force that it's being dragged down by gravity. A mass of 5 kilograms is raised through a distance of 100 meters in 10 seconds. What's the work done against gravity? So gravity's pulling it down by a force, and it's raised against that force 100 meters up. So it says, firstly, convert the mass of the mass of the mass, 5 kilograms, convert that into a force or a weight. So just insert an equation, mass times gravity, which is equal to 5 kilograms times, you'll be given the acceleration due to gravity, but we'll use 9.8 for this, which is equal to, get the calculator out, 5 kilograms times 9.8 meters per second squared is equal to 49 what though? 49 newtons, because it's a force. A weight is a force and it's measured in newtons. All that tells us is the force that we're going to be dealing with when we do work done. So on a new line, work done is equal to force times distance, and the force being the weight. That's equal to 49 newtons times 100 meters, which is equal to 49 times 100 is 4,900. 4,900 joules. If you wanted to do kilojoules, 4.9 kilojoules, but you don't need to use kilojoules. You know, the work done is still 4,900 joules, and that's that for that one. What's the power required to do that work? Well, power is how quickly you do work. Power is equal to work done over time. Which is equal to 4,900 joules and it took 10 seconds, so the time was 10 seconds. If I put S there just to remind myself I can do, then I'd put J here for joules. You don't have to do that in the middle of an equation. That's equal to 4,900 divided by 10. You just take 1 0 off the end. 490 watts. That was the power. So in no time at all, I've got 5 marks, which is a substantial amount to get in this exam. Question 3. Which of these is a unit of weight? Well, we know that a kilogram is a unit of mass, so that's not weight. Weight is a force, so we know it's the Newton. Which of these defines what power is? One or more answer could be correct. So power is work done over time. Time tells us that the word rate is relevant. So the rate of consumption of energy, or consumption of energy, is work. So power is the rate of consumption of energy. So that's correct. So the rate of doing work is power as well, because doing work and consuming energy are the same thing. But power is always to do with time. So whenever it says rate, or how quickly we do work, then that's what power is. Power is not the work done. That's the work done is called the work done. That's work. But work done compared to time is power. So in question 5, which of these defines work? This says the rate. No, that can't be right. The rate of which energy is consumed is power. That's not right. So that is work. Work is done when a force is moved through a distance, because work is force times distance. That's right. Next we've got an overhead line as a span, which is the length of 90 meters, and a tensile pulling force, big T, of 2 kilonewtons, which is 2,000 newtons. The line has a weight per meter of 1.62 newtons per meter. So that's how much it weighs for every meter of the cable. And it says calculate the sag of the line given the formula. Okay, no problem. So sag is S. So what I'm going to do, I'm going to copy this and I'm going to paste it, but I'm going to rearrange it. The S slides and rises, the T swaps and drops. So that's S, that's T. I'll copy it again, put the numbers in. W is 1.62 times L is the length, which is 90, so it's 90 squared over 8T. So that's 8 times the tension, and the tension is 2 kilonewtons, but we need to use the unit of newtons, so it's 2,000. And that's going to be equal to, I'll get Casio out. So 1 point, in fact, I'll just clear that off so you can see what numbers I'm pressing. 1.62 times 90 x squared to get 90 squared equals that. So the numerator is 13,122, and that's going to be divided by, so press divided by, and I know that 8 times 2,000 is 16,000, but if they were harder numbers, I would do divided by, and then I'd put them in a bracket. 8 times 2,000. Close the bracket off. And it gives us a nasty looking proper fraction, which I will change to decimal. 0.82 meters. There you go. 0.82 meters. That's how much the cable sags down due to gravity when the line is 90 meters long and it's got a 2,000 Newton tensile force pulling on it. Define energy. Well, energy is the ability to do work. So if you look at the top and everything that I've put in here, energy is a capacity for doing work. So copy that. There you go. A resistor has a current of 2 amps flowing through it. Its resistance is 1 kilo ohm or 1000 ohms. What's the power? Okay, well, what we said was insert equation P equals I squared times R, where I is the current and R is the resistance, which is equal to 2 amps squared times the resistance is 1000 ohms. So 2 squared is 4 times 1000 is 4000, and because we used amps and ohms, the power is going to be in watts. Just double check that. So I squared R, where we've got 2 amps, press x squared, times the resistance of 1 kilo ohms. If you want to put it in kilo ohms in a calculator, you can do 1 times 10 to the 3 ohms equals 4,000 watts. So there's the answers for that, and have a check yourselves, and thanks for watching.